All right, so we are on day 2 of rational functions and finding their discontinuities, aka guys. Hello. Hi. Finding your horizontal and vertical asymptotes or slant. So we talked about that there's things you have to identify and pay attention to. We left off on example 4, letter B. So here we have that function. So we have 3x over divided by x squared minus 3x plus 2. Okay, they're both polynomials. What is the degree of the numerator? 1. What is the degree of the denominator? 2. So in this case, n is less than d. Okay. So therefore, it's a horizontal asymptote at y equals 0. So when n is less than d, that means you have a horizontal okay. To find your vertical, remember their vertical is based off of your denominator. So you take your denominator and set it equal to 0. So I have x squared minus 3x plus 2 equals 0. Horizontal is based off of the degrees. That guy. All right. So in this one, you have a choice of doing the quadratic formula or to factor. Factors fairly quickly here. What multiplies to give me 2, but adds to give me -3. -2 and -1, right? A negative times a negative is a positive, and a negative plus a negative is a negative. So therefore, my vertical asymptotes are where? What would x have to be in order for this to be a true statement? X could be 2, right? Because 2 minus 2 is 0. And x could be 1, because 1 minus 1 is 0. So that's where my vertical asymptotes are. How do you feel about a horizontal and a vertical? All right, so we're gonna take a gander at the map, not the map. What's that thing called? The graph. So if we look at the graph of this, I'm gonna go to y equals. Remember, when you're putting in the graph, you want to protect your numerator and protect your denominator by using parentheses. So when I hit graph, so see how my curve approaches? So it approaches along the 0, and then it goes up, approaching 1, but it doesn't touch 1. Then on the other side, and the inside, you also can examine the table, and you can see where you have errors. So notice I have an error at 1 and 2. Why do I have an error at 1 and 2? Because it approaches, those are my vertical asymptotes, right? So that's why there's errors there. And then notice that my y values are getting smaller and smaller. They're trying to get closer and closer to 0, but are they going to actually ever touch 0? Mm-mm. All right, questions? All right. So we're going to look at example C. Example C. The numerator equals the degree of the numerator is, the degree of the denominator is. So in this case, n is greater than d. What does that mean? It's slant, it's oblique. So it's not a horizontal. We have a slant, or whatever you want to call it, oblique asymptote. And this one we have a choice of doing long division or simplifying and doing division. So x squared minus 4, this can be factored, right? So it can be factored into x minus 2 times x plus 2. Do we all remember difference of two squares? Difference of two squares, dots. Or what multiplies to give you 0, but adds to give you -4 in sense. So when you have x squared, you have plus 0x minus 4. So what multiplies to give you -4, but adds to give you 0? It would have to be -2 and +2. That's what happens every time you have difference of two squares. Okay, right, Maddie?
Right.
Mm-hmm. All right, so what happens here is instead of having to do long division, I can factor out. When you can factor out, this creates a whole new type of discontinuity. It's called a removable discontinuity. Removable discontinuity. Okay, AKA a hole. There's a hole in my graph. You get it, good job. Okay, there's a hole in my graph, and there's a hole in my graph at x equals 2, because that's what I took out. And then what's left is my slant / oblique. And what am I left with? X plus 2. Do we see that? So x plus 2, that is my slant. So I have a slant asymptote at y equals x plus 2. Okay, and because x minus 2 is eliminated, there's no vertical. Because of this right here, the elimination of it, there's no vertical asymptote. So the two discontinuities that I have a removable at x equals 2. And I have a slant asymptote at y equals x plus 2. So let's look and see what that looks like as a graph. So I'm going to go to my graph. Protect my numerator, x squared minus 4 divided by, protect my denominator, x minus 2. Hit graph. And what is it? It's just a line because of the elimination. So because of the elimination, it's just left with the slant asymptote. Now it's really hard to see too, but if I go second trace and I go to value and I type in 2, it tells me nothing. Why does it tell me nothing? Because what did we say there's the problem is at 2. Is removable. It's a hole. It's a hole in the graph. It's really hard to see the hole. I'm going to try to zoom in on it for you. Still can't even see it, but it gets harder to see it. But if you go to the table and you go to 2, you'll see at 2, it'll say error. And the reason why there is an error is because there's a what? A hole in the graph. Yeah, it's literally a hole. A little tiny hole in the graph at 2, 4. I think you can see it better on Desmos or on the other one, just not this one. All right. So now we're going to talk about graphing rational functions. So when you're graphing rational functions by hand, which on your test, there is a part where you have to graph the function. These are the steps we're going to follow. You find your asymptotes. You factor your numerator and denominator. Find your holes. and vertical asymptotes, and then you sketch everything. And then you're going to find points to the left and the right of the asymptotes, and then plot and connect. So those are the steps that we're going to follow. So I'm going to give you a moment to write them down, look at them, take a picture, whatever you're going to do. But those are the 5 steps we follow. Ready, Freddie? No. It would have been better if you said sure, Sherry.
Sherry did sound right. If Betty was the first thing that came to mind.
I should have said sure, Sherry.
No. Betty, like, my brain wasn't thinking at the moment. Like, I don't know. It just came out.
I say ready, Freddie, because it rhymes.
Okay, and sure, Betty sounded good to something because it came out of my mouth.
All right. All right. Mark, get set, go. All right, so we have here, we're going to sketch a graph. We have y equals 1 over x minus 2 and identify any asymptotes. If you want graph paper, there is graph paper in the little box that says graph paper on it. Otherwise, you can just sketchy sketch. All right, so what does step 1 tell us to do? Find horizontal asymptote first, right? So horizontal is based off of the degree of our numerator and the degree of our denominator. So the numerator here is 0. The denominator here is 1. So n is less than d. What does that mean? That our horizontal is what? If n is less than d, then our horizontal is 0. Okay. If n is less than d, then our horizontal is 0. So we have a horizontal asymptote at y equals 0.
Who turned this up? Yes. Yeah. On the 3rd of May.
It's on the board right there, Maddie. You weren't here yesterday when we went over it. All right. Next, what was step 2? Factor. So number 2 is to factor. Well, it's already factored, right? Check. Step 3. Find holes. So if I look here, I have 1 over x minus 2. Can anything be eliminated? No. So there's no holes. Then what was left? To find the asymptote, right? So that means I set my denominator equal to 0 to find my vertical asymptote. So where's my vertical asymptote at?
2.
At x equals 2. So I'm going to go to x equals 2. My 2 just didn't make it. And put in my vertical asymptote at x equals 2. Okay, what's the next step? I did. Check. Sketchy done.
Oh, 5.
Now we're on the find points. Find points? Yeah, it was. It was step 5. Find the points to the left and right. So I'm going to choose any point. So any letter. So I can choose 1. 1 is pretty easy to plug in, right? I can choose 1. I can choose 2. Well, not 2. Anything to the left of this. So if I plug in 1, so if I substitute in 1, I have 1 over 1 minus 2. What does that equal? That's 1 over negative 1. Don't know why we were all silent about that. I said, what is 1 minus 2? And no one answered me. And no one answered me. I was just wondering what was going on, but. So therefore at 1, it's at negative 1. Number 5 is choose a points to the left and to the right and plug them in and evaluate. So I chose 1. All right, now I'm gonna go to the other side and I'm gonna choose a point. 3 or 4, what do we wanna do? 4. So we plug in 4. 4 minus 2 is what, guys? Good job. So we're at 4.5. So I go to 4 and I go to 1/2. So what this just tells me is that the relative location of my graph, and I'm just going to connect and follow it out. But do I ever touch those asymptotes? No. And there it is. All right. So from here, you should be able to tell me the domain. You should be able to tell me the range. You should be able to tell me if there's an intercept or whatever happens here.
What happened to wine?
Okay. All right. So again, we have this. Here's our sketch. Was that terrible? Okay. So if it asks you for the domain, your domain is from left to right. What's happening? So it starts off at negative infinity, right? And then they're traveling along. Oh no, there's an asymptote. I have to stop and then restart. Because you go left to right. Then your range is bottom to top. So again, I started down at negative infinity, traveling along. Uh-oh, I have to stop. And then I continue to travel on. And that's your domain and range of this graph. Your asymptotes cause you to do what? To stop and start over. Okay. Your asymptotes cause you to stop and start over. Exactly. All right. Example 6. So example 6, you have a couple options here. You can read it as a transformation. If you choose to do that, that's pretty useful if you remember your transformation rules. So transformation rules, if I have something with X, that causes us to go left or right, correct? And our X's are what? Liars. So even though it looks like it says X plus 2, what is it actually doing? -2. So my parent function is actually shifting to the left, right? And then I have a -1. So what is that telling me?
It's going down.
It's going down. So those values represent your C and D of your transformation. So if the transformation works like this, f of x equals 1 over x minus c plus d, where c tells us whether we're going left or right, and d tells us whether we're going up and down. Does that ring bells? Okay. All right. So just remember your parent function for this. I'm going to sketch the parent function first. So your parent function is f of x equals 1 over x. That's the rational parent function. And it all starts at the origin. You have a vertical asymptote at x equals 0, and you have a horizontal asymptote at y equals 0. sorry, your points of, you have 1, 1, and you have negative 1, 1. So this is your parent function.
So we have to graph it here.
No, I'm graphing it so you can see why I'm shifting things. So based on what we have here, we need to do what to the parent function? We said we're moving everything to the left 2, and then we're moving everything down 1. So I'm taking my asymptote. So a vertical asymptote is being moved left 2. My horizontal asymptote is being moved down 1. And I'm going to do the same thing to my points. So this is going to go left 2, 1, 2, down 1. This point's going to go left 2, 1, 2, down 1. And here is my transform function. So this is your other option of graphing using your transformation rules versus the 5 steps. Okay, so you still have the knowledge of transformations that are applicable. All right, so we're gonna try example 7 without doing the parent function first, just talking about the transformation. So if you notice here, if I'm in transformation form, my C tells me my what?
Your Y.
What asymptote is that? The vertical asymptote, right? Your vertical asymptote comes from your C, and your horizontal asymptote comes from your D. Okay. If you're in parent function. All right, so let's test it out again. So now that we've come to that conclusion, looking at what I have here, I have g of x equals 1 over x plus 1 minus 1, right? So without having to sketch out our parent function again, let's talk about it. What is my C? Negative 1. And that's because x is a what? Liar. What is my D? Negative 1. So that means that since C is negative 1, I have a vertical asymptote at negative 1, right? Because D is negative 1, that means I have a horizontal asymptote at negative 1. Do we see that? So all I have to do is go to negative 1, draw in my vertical asymptote, draw in my horizontal asymptote. Because why lie? D doesn't lie. Only the x's. That says minus. That's because it's exactly what it is. If it's plus D, you're going up. If it's minus D, then you're going down. Only the x is the backwards. All right. So then the same thing goes for your points. So your parent function points are at 1, 1 and negative 1, negative 1. I'm going to move each one of those accordingly. So they're going to go to the left 1 and they're going to go down 1. So I'm going to go left 1 and down 1. I did not move my asymptote. My asymptote is not at negative 1. And no one was going to say anything to me. Yeah. Okay, tell me where. He said he's a little confused. So my C is negative 1, which is my my vertical. My D is also -1, which is my horizontal. And then my points, they're normally at 1, 1, and -1, but I got to move them with the rest of the graph. So we went left 1, down 1. So from here, went left 1, down 1. And I'm going to follow the curves now. Follow the asymptotes. Same thing over here. We were at your parent function. So when look at your parent function, it's always at 1, 1, and -1, -1. That's where the parent function is. If I plug 1 into this, I'm going to get 1. If I plug in -1 to here, I'm going to get what? -1. Yeah. Remember, functions are something that you can input and get an output. So you can always check if you don't remember. So if I exactly from the parent function. It said to sketch it, but I didn't want to sketch it. All right, good questions. Any other questions about this form? Okay. All right, so that's transformation. Now we're gonna go back to not being in transformation form. Whatever's over there is what's left. I will not be buying any more supplies. All right, so here. We're going to talk about these two. So we're gonna look at their N and D. The degree of the numerator is 2. The degree of the denominator is also 2. So that means we have an N equals D situation. When that happens, all you're focusing on is the leading coefficients. So my leading coefficients are 0.5 and 1. So what is 0.5 divided by 1? We all agree? 0.5 divided by 1. That's what I just said. We're all in agreement, right? It's gonna write a half. So that means that my asymptote is at y equals 1/2. So I'm gonna go to 1/2. It's your horizontal. Remember, this is your step 1 is to find the horizontal. So we have a horizontal asymptote here at y equals 1/2. After we find our horizontal asymptote, what do we find next? The vertical, and the vertical is based off of your what? Your denominator. So we have x squared minus 9 equals 0. So that gives us x squared equals 9. So x equals +3 and x equals -3. So I have 2 vertical asymptotes. One at +3 and one at -3. Uh-oh. And then we have +3. And then we're just going to substitute values in to see what's happening. So if I substitute in -4, is it okay if I do the math out loud, or do y'all want me to write it out?
Are you putting the -4 with the x's?
Do it out, huh? Okay, so -4 squared is regular 16. What's half of 16? 8. What's 8 plus 1?
9.
So my numerator is 9. And then what's 16 minus 9? 7. So this is roughly at 1 and some change. I'll put you right here, buddy. So it's gonna do this. There's that part. Now I gotta find the middle. I'm gonna do 0 because it's gonna be the fastest thing to plug in. And that's just gonna give me -1/9 because 0 is gonna make everything, all the variables go away, right? So I'm left with -1/9. So I know that's in the denominator, not denominator, in the below the axis. Somewhere right there, close enough. And I'm just gonna follow the curves. And that's the most curvaceous thing you've ever seen. I said it. Uh-huh. All right, and then this one, if I plug in +4, it's gonna do the same thing as -4 did, right? So it's gonna still be roughly 1 and some change. And there is my rational function. The domain here, I'm gonna write it in another way. So we've practiced writing an interval. Now we're gonna write it in set. So my domain is X, but X cannot equal what? X cannot equal +3 or -3. Because that they have what? Huh? I was just writing as another option. So you could do the long one. The long one would be from -∞ to -3 union, -3 to 3 union, 3 to infinity. If that's how you want to write it. Pick which one. But so one's written. I personally would choose this guy. But if you want to write an interval, I won't stop you. All right. So these are just more examples of us going through and evaluating and practicing the graphing. We can keep going. We can do more practice. Are you feeling okay with identifying the vertical and the horizontal? Yeah. So this is another example. It's a little different. There's so many different possibilities. I try to give an example of each. So here we have 3x squared plus 5x minus 2 divided by 2x squared. Ryan, may you please stop? Plus 3x minus 2. The numerators are going to have the same degree because the numerators are equal. The degree of the numerator and degree of the denominator are equal. Your horizontal asymptote is at y equals 3/2. And it's because it's based off of your leading coefficients. And what are my leading coefficients? 3/2. So my horizontal asymptote is at 3/2, so 1.5. Guys. You're not canceling them out. When the degree of the numerator and degree of the denominator are the same, all you're focusing on is the leading coefficients. And that's because over time, as the numbers get bigger, that's all that's going to be remaining. 3/2 is 1 1/2, right? $1.50, 1.5. So we're here at y equals 1.5. All right, now to find your horizontal asymptote, it says to go ahead and factor. So for the sake of time, we're going to factor this. So the factors would be the factor of the numerator. This is 3x minus 1 times x plus 2. Factors of the denominator would be 2x minus 1 times x plus 2. So after you, exactly. So after you factor, you're then gonna find any holes. What do I have a hole at? At x plus 2. So there's a hole in my graph at x equals -2. The factor, what one? Where do you see -1? 3x minus 1. Because when you factor, what multiplies to give you -6 and adds to give you 3, and you go through grouping or box or, yeah. Yeah, 3 times -2 is -6 when there's 1 in front. All right, and then your vertical asymptote. So where's your vertical asymptote coming from? What's left in the denominator? Oh, what's left in the denominator and what's left in the denominator? You're left with 2x minus 1. And what is 2x minus 1? So what would x equal? X would equal 1/2. So you have an asymptote at 1/2. So then, yes, he was on time. Well, he was only a minute late yesterday. So at -2, when you substitute this back in, you would get 7/5. So you were at like about 1 2/5. So I'm gonna go to 1 2/5. There's gonna be a hole here. So there's a hole there, and then it'll continue its way out. And then up here, just kind of follow the curves. And here would be that. And again, your hole, if you all you're doing is substituting x in, and you'd be left with 7/5. And so therefore your domain here would be x, but x cannot equal was 1/2.